Okay, so in the conventional potentiometry, you're familiar with reference electrode and then indicator electrode. In the conventional potentiometry, you will need a salt bridge here to balance the amount of the ions in both beaker. But in the modern potentiometry, we only need one beaker. As the substitution of the salt bridge, we will use this one. The green one here is the porous membrane. The porous membrane is used as the salt bridge to balance the amount of the ions in the solutions. And and there are many types of reference electrodes. The one that you already know is HE, or standard hydrogen electrode. Actually, there are another reference electrodes, so-called SCE, saturated calomel electrodes. It's made from HgCl2. It's mercury chloride, and another one is silver chloride. This is what we are going to use in this experiment. And different like in the potentiometry, since there are no current flowing in the system, in the voltammetry we will add the current. That's why we will add this one, power supply. Power supply and the voltmeter, if we pack them together, we call it as potentiostat. And in addition of the current, we will need counter electrode. So that's why in voltammetry we will need 3 electrode systems. Reference electrode, here the first one is reference electrode. The second one is the working electrode. Instead of indicator electrode, we call it as working electrode. And the last one is the counter electrode. So that is the brief explanation about voltammetry. Okay, so this is the full setup of the voltammetry. First one, we need this one. This is what we call potentiostat. Potentiostat is used to control the applied voltage as well as measuring the current. Next one, we move on to the application. So this one is the program that we need to use for voltammetry. Of course, it's connected to the PC. Okay, next one, we need electrodes. So this is that we talked before. It consists of 3 electrodes. The first one, the one with a circle pattern here, is the working electrode, and the silver dye here is the silver chloride reference electrode, and the one with C pattern here is the counter electrode made of carbon ink. First thing first, we need to turn on the potentiostat. Press this button and then click once more to turn off the Bluetooth, and then let's go to the program. Click connect until it's shown connected here. Okay, so it means that the potentiostat is connected to our PC. Next one, if we would like to measure the first one, we want to measure the baseline. Here I used electrolyte sodium chloride, 0.1 mole per liter, and I use micropipette to transfer 63 microliter. Then drop it on the surface of the electrode. Then click start to start the measurement. So this one is the signal of the baseline. We'll measure it 3 times because here the number of scans is 3. So meaning we would like to measure the baseline 3 times. 3 cycles. Okay, so this is the result of the baseline 3 times measurement. Okay, next one, we would like to measure 10 millimolar of potassium hexacyanoferrate in sodium chloride 0.1 molar. Okay, I'll take 60 microliter and then using this electrode, then drop it. Okay, next, let's click measure. Again, if we would like to open the previous measurement, we can go to data and add data from files. This one is the baseline. Okay, so this one is the baseline. These 3 colors, red, green, yellow, is the baseline, and the blue one here is the signal from potassium hexane cyanoferrate 10 millimolar. So as you can see, it provides 2 peaks here. The upper peak is anodic peak, which means oxidation, and the below one is the reduction peak. So this is the result after 3 times measurement of potassium hexacyanoferrate. So as you can see that the peak height of the reduction of the oxidation peak is 0.145, and the reduction peak is 0.139. So if we this one divided by this one is equals to 1, meaning that the molecule can be oxidized as well as reduced at the same time. What if a molecule can only have this peak, the oxidation peak? So it means that the molecule can be oxidized only. If the molecule only have below part here, below peak here, so it means that the molecule can be reduced only. Okay, so if we would like to save the data, you can save in this format by clicking data and then save data. Because I already saved it, so click save. Okay, so if you would like to transfer the data to Excel format, you just need to click the data here and then copy paste this data. Okay, so that's all.